So we looked at measures of center, which measure the center of data. Measures of variation in data. Now we have measures of position. What will that measure? Position of what?
Data.
The entire data.
Specific.
Specific points in the data. So the objective of measures of position is to determine where one observation lies relative to every other observation in the data. Here is a question. There is one statistic, one measure of center that we've already seen that is a measure of position also. Which one is it? There is one measure of center that is also a measure of position. Someone said it. Median. Why? Why?
I don't know, but it just sounded right.
It's the middle of the
The
data.
middle of the data.
It's right in the middle of the data. So the middle.
Relatively.
I'll show you this.
Close enough.
Close enough. So the median cuts the data right in the middle. So that is actually a measure of position. Now, the name that we use for measures of position is percentile. What is the key word in percentile? Percent. So it has to do something with percent. So we call a number a certain percentile depending on the percentage below that number. So if I call an observation as the 10th percentile, typical notation is P10. That would imply 10% of the observations I'll call it X. Lie below X. If it is the 20th percentile, 20% of the observations would lie below the 20th percentile. 30th, 30% below, 30% of the observations would lie below the 30th percentile. That said, what percentile do you think the median is? 50. Very good. So median is the 50th percentile. What about the minimum? 0. What about the maximum? 100. If I split this lower half of data exactly right in the middle, hopefully, 25. That would be P25, because 25% would lie below and 25% would lie above, and in total 50% would lie below the median. Good. Likewise, if I cut the upper half exactly in the middle, what percentile would that be? 75. Good. So these are quarters, correct? Quarter, second, third. So Q1, Q2, Q3. Q1 is the 25th percentile, Q2 is the 50th percentile, Q3 is the 75th percentile. We can also measure percentiles in steps of 10. In other words, P10, P20, P30, P40, all the way up to P100. So they are called deciles. But you don't have to know deciles and quintiles and all that. All we need is quartiles and a percentile, because a percentile is more accurate in the sense I could say P63.5, that would imply 63.5% of the observations would lie below it. Does that make sense? Computing a percentile is quite easy. I don't want to confuse this with the X we just talked about. So if you pick any observation from the sample, then the percentile of that observation simply can be calculated using this formula. So you count the number of observations that are below or equal to y, divide by the total number of observations, and multiply by 100 to get it as a percent. Of course, your book is very special, so it doesn't include or equal to, just below y. We can include y also. This is what the book does, so I'm going to stick with that. You round it to the nearest number. You don't round up, but you round to the nearest full number. But in practice, though, we don't even round. You know, as I mentioned earlier, I could have something called P sub 63.75. That is more accurate. But I can't go to the general population and say, oh, the number 84 is P63.75. No one's going to get it, right? They'll give me looks. But if I said this is P60, 60th percentile, then 60% lies below that number. It's easier.
Oh, wait, we go to like nearest tens.
Huh?
We go to like nearest tens, that would be 60 instead.
Exactly. Instead of giving like 63.75,
Instead of like 64. Oh, yeah.
P60. But this is what I would go for because it's very accurate. So any questions on the formula? We'll do an example if it makes sense. Number of observations, you just have to count below y divided by the total number of observations. We multiply by 100 to get it as a percent, rounded to the nearest full number. Good.